Returning to the basketball player from the previous video, recall he's accused of making less than 83% of free throws overall. When given the opportunity to shoot 10 free throws, he only made 5. Is this evidence of him being less than an 83% free throw shooter? To answer this, we simulate sets of 10 free throws to estimate how often only 5 or less should be made. Each set of 10 free throws is known as a trial of the overall simulation. Instead of rolling a 6-sided die, we're going to use random digits to simulate free throws attempted. There are 100 two-digit numbers from 00 through 99. We'll choose 83 or 83% of these numbers to represent a made free throw and the other 17% to represent a miss. While other instructors may promote a slightly different approach, I propose the following components for various aspects of performing a simulation. First, you'll want to identify the outcomes. We will say every two-digit number will be a free throw attempt, a 00 through 82 will be a made free throw, 83 through 99 will be a missed free throw. Then we'll need to identify the procedure and what we're going to end up recording. For each trial, a string of random digits will be used to select the first 10 two-digit numbers. We will count how many of the numbers are from 00 through 82. This corresponds to number of free throws made in 10 attempts, and it will be the number we record. We will perform 50 trials, or whatever the problem suggests. Now discuss the data and how it's going to be analyzed. Once our 50 trial results are recorded, the relative frequency of making 5 or less free throws can be calculated. We'll use this probability estimate to reach a conclusion. Oftentimes on an exam, you'll be asked to show the first 3 trials on a set of random digits and mark them up. So we'll start with the first 10 two-digit numbers. We'll put a vertical segment just after the last number in the trial. We're going to circle the made free throws and then record the total made free throws above or below the random digits used. And then we can use the results to answer any questions in the problem. Now, how to produce a simulation is really dictated by whatever question is being asked. In this problem, the question was, by only making 5 of 10 free throws, is this evidence that the player is less than an 83% free throw shooter overall? Responding requires the following huge idea, so listen and watch. The results we get from our 50 trials are exactly the kind of results we would expect from an 83% free throw shooter. It's not the results from this one individual who made 5 out of 10. The reason we know these are the results typical of an 83% free throw shooter is that we set up the simulation that way. We forced 83 out of the 100 two-digit numbers to be a free throw made. So, knowing that we're looking at the kind of distribution results you should get if you're an 83% free throw shooter, now consider the one and only sample of size 10 from this individual. He only made 5. So by looking at the typical results, we could see an 83% free throw shooter would only make 5 or less free throws in about 1 out of every 50 samples. That's just a 2% relative frequency. So this is evidence to convict beyond a reasonable doubt of 5% that this player is less than an 83% free throw shooter.